Hey everyone, I wanted to showcase a quick demo on how the new llama-4 models can be used with Fireworks for an agentic workflow. In this case, our tool performs deep iterative research on academic topics by searching ArXiv, which is an open website with millions of papers, and analyzing papers to generate comprehensive reports. So let me walk you how this works. The system follows this flowchart architecture, which I found from an open source GitHub repo. It's designed around an iterative refinement process. So first the user would input, along with their query, a couple of parameters. The first key one is the depth. So this is the number of research iterations to perform. Each one of these builds upon the next one. And the breadth is how many parallel query paths to explore per iteration. The core workflow is like a recursive loop. So we generate targeted search queries based on the current context. We fetch relevant papers from ArXiv. These would be determined by the breadth parameter. We process and extract key insights from those papers. We identify new potential research directions, and then we choose the most promising direction and loop back for the next iteration. We do this the amount of depth times. Each iteration gives us both concrete learnings and also new directions to explore. And if we haven't reached our depth limit, then we select the most promising direction and we start another iteration with that new context. So all of this would be performed by our agentic workflow. So really quick, why llama-4? We specifically chose llama-4 models for a few important reasons. The first one are its reasoning capabilities. So llama-4 excels at extracting insights from complex academic text and identifying connections between concepts, which is really important for determining research paths. Because this is a multi-step process, we have llama-4 expertly deciding where to take the research and what direction to go based on previous findings. Another reason is parameter efficiency. So llama-4 models like Scout and Maverick use a mixture of experts architecture, which means they only have 17 billion active parameters, but perform at the level of much larger models. So Maverick outperforms both GPT-4o and Gemini 2 Flash across many benchmarks, and it's much more efficient because both of these models have many more than 17 billion active parameters. Finally, the context window. So llama-4 Scout offers a 10 million token context window, which is almost infinite. This would potentially be equivalent to a couple hundred of research papers, so you could really increase your depth and your breadth without bound. So let's look at an example query. So I'm going to paste this query that I have. As you can see, it's a bit of a mouthful. So we have fast inference, allowing for real-time translation glasses with many languages simultaneously, with noisy environments, with the use case of restaurants, street markets, right? And then also asking for breakthroughs in the space. So this will definitely require more than one research paper to answer a question. And we'll have to probably pivot a couple times as we search for our papers, as we learn more about the subject. This will all be done by our AI agent. So all we have to do is pick our parameters and then let it perform its research. So while this runs, let me talk a little bit about Fireworks. So Fireworks specializes in low latency inference, and it's in use cases like this where low latency is really very valuable. So every time we run deep research, we have LLM calls being made to search for documents, process those documents, and also decide where we are taking our research next. And this is done over a number of iterations. So this would make this task quite latency sensitive just because we have so many requests stacked up upon each other, especially as we increase our breadth and our depth. So as this is running, you can see kind of what the research agent is doing, how it's changing its research direction, and all the things it is searching for. So if I skip to this completing, we can see that we have finished our research. We analyzed 48 papers across 3 iterations and a bunch of key insights. If we look at how long this lasted, we can look at our detailed research log, and it seems like it took just over 1 minute. And if we would want to look at our iteration results, see what it searched for, see how it kind of moved along the research process, we could also do that here. But here's our final research report. So we have a summary, we have some key findings, so Laplacian pyramid translation, a couple of speech algorithms. We have things like adversarial training, data augmentation, speech emotion recognition, really a number of topics that you wouldn't have been able to find unless you were iterating and modifying your paper searches as you go and as you learn things about this industry. We have some detailed analysis, and then finally our conclusions and our references, so quite a number of sources. It did all this in 1 minute, which is pretty impressive for a web search agent, especially that looks at so many papers. If you look at the other models that are available, so we have llama-4 Scout, also through Fireworks. This is the high context window model. And then we also have OpenAI's GPT-4o. We could call this through OpenAI, as well as any other model hosted by Fireworks. I just finished running this with OpenAI's GPT-4o. If we see how long this took, it seems like it took just over 2 minutes. So it's twice the amount of time as it did with Fireworks. And if we were to increase these parameters even more, we would see that overall latency increase drastically. So would have a really high impact on our overall research experience. If we look at our report and our key findings, we do see some overlap, but in general, we do see less key findings, less amount of novelty and new papers that were extracted, which just demonstrate the power that these llama-4 models give us in conducting research and moving that research along, and in extracting and processing industry-leading papers. This is a simple demo that shows how these state-of-the-art llama-4 models can leverage Fireworks' fast inference to create powerful agentic tools. The code is open source, so feel free to try it out.